Have a get lonely.
Morning, everybody.
Morning, Zach.
Good morning.
Hey, last day. What do you guys want to do? Fire away. Give me questions. Let's get you ready for next week.
I don't really have any questions.
Well, at the end of the class last time, I told you we could do another example of using analog to control analog, if you guys want to do that.
Okay.
Everybody getting everything turned in okay?
Yes.
Good. Okay. All right. Well, using what we have, what analogs in do we have? We have the distance sensor. We have temperature, water temperature, air temperature. So somebody pick one of those.
Let's do water. Let's do temp.
Water or air?
Air.
Okay, I don't know how well that's going to work only because,
Then water.
okay, yeah, water's going to be slow, but we can use it. Air will work. It's just I think I've toasted that thermocouple by putting the torch on it too many times. But
Oh, gotcha.
all right, so let's.
Wait, then for the final we have to do temp with the fan. So how is that gonna work?
I don't know.
Okay.
It will work well enough if I decide that that's the one that I'm going to give you guys. You should be prepared to use any of them, right?
Yeah.
But if you are told to use the air temperature, it will work well enough, and I'll be able to know by your logic if you know how to do it, right?
Okay.
I guess I need to share my screen. So who wants to do the screen control? Volunteers. Need a volunteer.
I think I just heard Nate volunteer, right?
I'm on my phone.
Anthony, you want to do it? Tyler? Tyler, are you working?
I should have forgot about.
Yep.
Anthony? What about Brad?
Yo, I haven't heard from Brad in a while.
I don't really have a mouse right now. I don't like using a trackpad.
Just give it to me so we can get it over with.
Oh, Dawn, don't say it like that.
This is like I'm always doing it. But I
That's
guess
good practice. Hey, it's good practice.
yeah.
I would do it if I had my laptop.
Nobody has to do it. I mean, we can just quit. I don't care. I mean, this is your time to get ready.
Oh no,
No.
I want to review. I want to go over this.
Okay,
No.
so let's use.
You said air temperature.
Yeah.
Are we doing water or are we doing air?
Water.
Oh, okay.
Okay, Don, it's going to you. Everybody get involved.
Okay.
Okay.
All right, so are these locked or something?
What?
They won't let me click. Oh, there we go. It just took a minute. Let's start with Celsius.
I wouldn't do that.
Why?
Well, go ahead and start. Maybe you'll see why. Anybody know why?
Why aren't we doing the water temperature?
Yeah.
Isn't it already in fair?
What?
Never mind.
I'm confused. Don't we use CPT to convert Celsius to Fahrenheit?
Yeah.
The water one reads in Fahrenheit, though.
Yeah.
What'd you say, Brayton?
The water temperature thing reads in Fahrenheit.
That's exactly right. That temperature sensor
Fahrenheit.
gives you an output 4 to 20 milliamps, 0 to 400 degrees Fahrenheit.
So was I right? I was right. She just spoke up. Never mind.
So,
Hey, if it already reads in Fahrenheit, now I'm confused.
Well, I'm not going to do your final for you guys. So you guys need to show me that you can figure this out.
Yeah.
Well, then I wouldn't need to do the formula. I would just put it in.
Okay, put it in.
That is in local 7.1. Temp sensor.
That's air temperature.
That's the air one.
Mm-hmm.
Then I am in the wrong spot. Does anybody remember which one the water sensor's in?
It's in there. It's just not labeled. All right, look. What you're trying to do a formula, and you're trying to output some number to something that's an input, right? Anything that's on module 7 is an input. It's going to read whatever the sensor is telling it. So it's going to read a temperature, and it's going to input something to the PLC, right?
Yeah.
So no, we're not going to make the compute destination an input.
We use a float.
Yeah.
So what are we looking for here? The water temp sensor is module 7, channel 1.
The only reason I'm putting the destination in is so I can easily copy it.
Oh, well
Okay.
then module 7, channel 1 for the water temperature sensor.
I'll change this back to an F8. And then since we don't need a formula, I would just simply just put this in, wouldn't I? That's all I would need because there's no formula needed.
Yeah, there is. We have to interpolate that and turn it into Fahrenheit.
Okay, wait. You're right.
But you told
Right.
you
But
told me that it was already Fahrenheit though.
The water temperature is reading Fahrenheit. It's outputting Fahrenheit. So if you ran this right now, Don, what would you see on F80?
I would have to go to. I would see 9,953.
Yeah. So is that the temperature in Fahrenheit?
No, it's just you're confusing me.
Huh?
It's a signal. You know how it reads in like 6,241 to 31,206.
Yeah, I understand. I understand that. It's just when I was trying to do that, everyone was saying it was already in Fahrenheit, so it confused me.
Okay.
All right, well, I'm confused now.
All right. So now I just got to put in the formula. All right. I'm not sure how to do this without going through Celsius first.
It's literally the same thing as Celsius,
So,
but since it's
subtracted. Yeah.
that is reading in Fahrenheit.
Okay, so input minus. All right, hold on. I'm gonna put this in parentheses. Input minus 6241,
Yeah.
and then divide that by 31206 minus 6241.
Yeah.
And then that would give us the percentage. Do you want me to multiply it by 100?
That'll give you a percentage.
Yeah.
That's not going to give you degrees Fahrenheit.
The sensor reads 0 to 400.
Yeah.
So we would multiply it by 400.
Correct. What if that sensor out was rated to give you 0 to 100 degrees Celsius?
Is that
Now
when you
times it by 100.
Yeah, on rung 1. What if it said 100 to 300 degrees Fahrenheit?
You
100 to
multiply
what?
by 200.
You multiply
yeah,
that by
the
200
range?
No.
Then you'd have to add that by 100.
and add it to 100. That's right. But right now, exactly what you have will output to an F8 the temperature in Fahrenheit.
Okay.
Okay?
Yeah.
Equals 7, 1.
Okay, so how can we calculate Celsius?
You then interpolate that number to Celsius, right?
No, we can just compute like the
I meant
Fahrenheit
compute.
number to Celsius. Yeah, we don't interpolate.
Yeah, we can just plug in the formula from Fahrenheit to Celsius.
Yeah.
Kenzie, I appreciate your feedback, but if you ever backtalk me again, I'm going to interpolate you.
You're funny.
No, but yeah, just use the formula that turns Fahrenheit to Celsius.
Turns Fahrenheit to Celsius.
Do you need that formula?
No, I got it. From Fahrenheit to Celsius. We would take the F8. F8.
Why are we turning Fahrenheit into Celsius?
Because we were supposed to.
Okay. I thought we wanted it in Fahrenheit.
We do, but we also want to see if we know how to turn it to Celsius.
Okay.
Just extra practice.
Do you know how to do it, Brad?
Yeah.
Brad?
Do you know how much wood it'd take a woodchuck to chuck some wood?
As much wood as a woodchuck could chuck if a woodchuck could chuck wood.
So since we're turning it to Celsius, it would be minus 32, not plus 32, right?
Yeah,
Correct.
it's minus.
Okay. And I need to put this in double brackets, don't I? Or, I mean, yeah. Okay. And then make this F81. Alright. Did I do a good job?
Hey, Don. In your formula for changing Fahrenheit to Celsius, did you do 9/5?
Yes.
It's 5/9. It's supposed to be 5/9.
5/9?
And you're supposed to subtract it from, you're supposed to subtract 32 before you multiply it by 5/9. So switch the order of that, because order of operation wise, it messes it up.
Okay.
In the first parentheses. No.
No, it'd be F8 minus 32
Minus 32,
times
yeah.
5 divided by 9.
Yeah, so, yeah. Right there.
Yes.
Right there. Yeah, minus 32. And then an end parenthesis times 5/9. Yeah. So you can delete one of the ones on the end.
Different than what we did before.
This because what we did before was Fahrenheit to Celsius. This is no, wait. Flip that. I'm sorry. We're doing Fahrenheit to Celsius. What we did was Celsius to Fahrenheit. That's why
Yeah.
it's different.
Okay, now enter that and see what you get.
Okay.
Why didn't?
I need this offline right now.
Oh, okay.
Right.
Yeah, we'll push it through so we can see the new number. Because it should be 16.
Oh no.
You gotta
Bless
run.
you.
Bless you.
Thank you.
Why are these in error? They're blank.
Yeah, you can just get rid of them right
Yeah,
for
give
right
me-
now, so that you clear the error.
I got my hash pipe done. I know Zach listens to some Weezer.
Which Zach?
You.
Hey, why
Weezer?
didn't the number change?
You not in run. Go to run mode. There you go.
There, yeah, okay.
So it's 64 degrees in Fahrenheit and 18 degrees in Celsius.
Yeah, it's
Very good.
yeah, that's good.
Hey,
Well
do me a
done.
favor, Don. Do me a favor. Before you go on, go into controller tags and turn the water heat stir on so we can see the temperature going up.
What's that under?
4.7, I think.
It's gonna have to be output. Output. Yeah.
Oh,
Click the plus.
there we go. What am I doing here?
Heat and stir. So
Turn it on. Press 1.
one, yeah, it's discrete.
Thank you.
Okay. What the hell?
It's yeah, it's gonna fluctuate until it starts really rising, but the fact that it's changing at all is good.
So now what are we doing?
Can we do the fan speed based off of that?
Yep.
Awesome.
Okay. Okay, so now the exhaust fan's supposed to speed up based off of the temperature.
Yep.
Yep, that's what we're doing.
Okay. So we would do. Okay. All right. I think I got it.
Good grief.
Mm-hmm.
on, what the hell?
You get used to it just like I did.
I
That's how
don't
you
know,
deal with
man.
kids. That's not how you deal with kids. Just deal with it. Get used to it. No.
Yeah.
My bad. What the hell did I just do?
Sorry, Dom. I was almost there once.
That doesn't make it any better.
Sorry. It's funny.
I was there once, then I ran away, changed states, changed names.
That run, it just didn't happen.
Hey, whoa, the fuck?
It wasn't that way. All right, don't assume that. Not get political, but wasn't that. Wasn't the big A.
Yeah, I think I did that right. And then I need a move command. Oh yeah, I need another rung first. And I need to move. Okay, and then I'm moving F8 to destination. It would be the fan, I think, so it would be local 6. And it would be the temperature fan. Oh no, it would be the exhaust fan, my bad. How's that?
Yeah.
Well, what's going to happen if you move the number 20,500,000 and some thousand? Does that seem right? If I wanted to put that exhaust fan on 60 hertz, what number would I need to send over there?
If you want to send it over to 60 hertz, then it would be 31,206.
That's exactly
Yeah.
right.
So we divide that by 100, remember?
Oh, so did I do this wrong?
You did, but I don't know why you're using F80 in there.
Yeah. That's our...
Because that's the temperature in Fahrenheit. That's what I was using.
Right. But why are you using the temperature in Fahrenheit? You're taking, right now, what is it, 60 some degrees?
Yeah.
64? So you're taking 64 times 31,206 minus 6241, and you're adding 6241. That gives you a ginormous number. I don't know why you're doing that.
Because that's what I wrote down in my notes from the last time we did this. I don't know what we were doing.
You need to take the percentage of numbers.
So
I understand that you're taking notes, and I appreciate that you're taking notes, but you have to understand what those notes mean. So F80 is the number 60 something right now, whatever temperature in Fahrenheit it is, right?
yeah, I know that. That's why I used it. Because I'm trying to use the Fahrenheit to calculate all this.
Right. So as that number goes up, you would want the fan speed to go up.
Yes.
That's right. But taking the number 62, like that's not gonna.
So
We'd want it in a percentage.
So
That's
if you
what
want
he's
it in a percentage, I need to divide it by 100.
But no.
But that's not going to give you a percentage either. Because 70, 60, whatever, what's the temperature in Fahrenheit right now?
Um, 90.
Okay. So that divided by 100 is not 91%. 91% of what? If you wanted the percentage of the range that the temperature sensor can read, how do you find that percentage?
You would take the low level. No, you take the top level minus the low level and then multiply it by 100.
So I would take F80 minus 6. What is it? It's 6241, and then divide it by 31206 minus 6241.
If you took F80 minus 6241 right now, what number would you get?
Like negative something.
Yeah.
If we were doing the percentage of the range, it would be the input minus 0 divided by 31206 minus 0.
That would be for the distance sensor, yes. You've already figured out what the percentage of the range is in rung 0. You took the percentage of the range and you multiplied it times 400 to give you a temperature in Fahrenheit.
So then I would need to divide it by. I don't know. I'm getting confused now.
Divided by 400.
That's what I was going to say, but I don't know.
Yeah. You could take that divided by 400. That would give you a percentage of the range.
All right. Oh, yeah. All right, so I need to just erase all that. So if I take F80 and I divided it by 400, that should give me the percentage of the range, right?
Yep.
And then
You're going to take that and multiply that by 60.
because that's the highest amount of hertz it can go is 60.
Because that's your range. And
Well, but that's not what we want.
Okay.
I mean, you could. You could have a rung showing you what hertz you want.
We could do the. So what is it? 60.
What do we need to output to the drive?
Well, you mean you're asking for current or
Either
a
one.
number?
Either one.
So 0 to 60 hertz, 4 to 20 milliamps.
Yep. We need to output 4 to 20 milliamps. How do we do that with a PLC?
With our numbers 6241 to 31206.
Yep.
So would we take our module, which in this case, what fan are we using? Temperature cooling fan?
The exhaust fan.
Exhaust fan. So we take module 6, channel 0, minus 6241 divided by 31206. Right? To find the fan speed?
We're going to determine the fan speed.
Oh, by using another number.
Yeah. So right now we have the percentage of the range of the temperature, right?
Yeah.
If we want that percentage to be equal to the percentage that we send to the drive.
So we have to interpolate our temperature range into our hertz range.
Yeah. So right now you have a percentage of the temperature right there as it sits. And we want to output, if that happens to be, I don't know, 30%, and we would want 30% of the fan speed going, right?
Yeah.
And that's all we would not want right there.
That's going to give you a percentage.
Yeah, and that's what we want is the percentage.
Because then if you run that, you're going to move
That number.
30% to the drive.
I don't know, I'm stuck now. You said you want to
compute what you're doing now.
You want another compute?
No, you're doing it now. Well, which one is that? That's water temperature.
This was the exhaust fan where we turned it into a percentage, and then I was using a move command to move that percentage into it so it would go at that speed.
So take that F8 minus 0, because that'd be our bottom range from hertz.
You want me to minus 0 right here?
Well, if F80 is our percentage, right? Or are we trying to make it a percentage now?
It's already going to be a percentage with what we have.
All right, well then subtract that by 0.
That wouldn't make sense, Brady, because it'd still be the same number, right?
Okay, well then don't subtract it by 0.
All right, everybody time out. Let me have it. I'm going to show you exactly what you have right now. Right now you have 29%.
Yeah.
So if the temperature percentage, right? What's the temperature range? 0 to 400.
Yeah.
So 29% of that range happens to be 118 degrees Fahrenheit. You see that in rung 0?
Right.
So what we're saying is when it's 120 degrees, output 30% fan speed. How do we do that?
Well, wouldn't we take that number and wouldn't we just take that number and interpolate it into the
hertz 0 to 60?
No,
Right,
not
don't we have to multiply it by 100 first to get us, so it's like actually at like a full number?
No.
no, that's fine as is. Wouldn't we interpolate it to the 6241 to 3206?
Yes. In other words, if I want the fan speed to be 100%, what number do I need to send to the drive?
31206.
If I want it to be 0%, what number do I need to send to the drive?
6241.
If I want it to spin at 30%, what number do I need to send to the drive?
Whatever 30% of those values are.
It's like 19,000.
30% of the range.
So we'd add. You're saying we'd add 6241.
30% of the range. Start there.
Give me a second, guys.
Okay, I got it all set up for you.
So the way I have it set up also is 32106 minus 6241 over 100.
Don, you want to keep going, or you want somebody else to do it?
I'm just really confused right now.
What are you confused about?
I mean, I'm just trying to figure out how to continue from where we are.
Let's look at the beginning. Rung 0. We assigned to an F80 the input of the temperature.
Mm-hmm.
The temperature input minus the bottom number divided by the entire range gives us a percentage. So whatever that input is, we're taking that percentage of the range times 400 to give us the temperature in Fahrenheit. Rung 1 is just showing us what that happens to be in Celsius.
Yeah. And then
Rung 2 is
Rung 2 is just the percentage.
Oh. Percentage of temp input. And it's also going to be
Okay.
so we have the percentage. Now we need to compute the fan output range. So how do we do that? Using what we have.
We would take F82 and multiply it by 31206 minus 6241.
Yep.
And then we're going to add it by 6241.
Yep.
I already did all the math on that. The final number comes out to 6489 65 times the F8.
What?
What did you say?
What? Just put it in. All right. What was it? I don't have control anymore. But all right.
All we need to do is put that F8 times it by 31206 minus 6241, and then add that by 6241.
That'll
Correct.
give us a
Yeah.
number proportional to our range.
Mm-hmm.
Zach?
Yes.
You have control.
Show them, Brayton.
Do I have control?
Wouldn't we take it over 100 though, because the interpolation formula calls for the range over range 1 over range 2? Or no?
No.
Oh, we
what
would-
Rung 3 computes is a decimal of the percentage, right?
Okay.
So
Yep,
if it's
you're
at
right.
50%, it's going to say 0.5.
So we don't need to. Okay, that makes sense. Sorry.
It's okay. So if we take that times the range we want and add all of that to the bottom number, that's going to give us an output to the drive. That's exactly what we want.
And we should be able to change this to the output of that drive, right?
Or you can do that. Yep. You don't even need the move.
Which one is that?
Should be 6-0 or 6-1. 6-0.
6-1 for the water temperature sensors, channel 1.
Wasn't it supposed to be F82, not F83?
We can
multiplying?
do that, or we can just do it directly through that. We don't need a move function.
What Brayton's doing is outputting the number that we need straight to the drive instead of outputting it to an F8 and then moving it to the drive. He just skipped a step,
Okay.
which is fine.
He's using F8.3 though instead of
Yeah.
using
I
F8.2.
think he means you got to use, and in our expression, we're using.
Oh, it's F8 too. My bad.
Oh,
My bad.
And
Oh, they call me the blind. Don't even know my day. Wonder a pirate's life.
all right. So you have to delete rung 4.
destination is 6.000.
And you can run it if you want, or we can put a rung in that tells us what the fan speed is. If we just do a compute instruction and take F8 2 times 60. It'd just be F8 2 times 60.
Oh, okay.
And this is just to show us what the fan speed is. Just send it to F8.3. Cool. I'm going to take over for a second. All right, I'm going to run this. And we'll see what just to make things easier, sometimes it's easier to look in the controller tags. I need to change the water heat and stir to on so it keeps heating up. All right, so water heat and stir is on, and then let's go look at our F8s. Water temperature in Fahrenheit is 160 degrees. Water temperature in Celsius is 70 degrees. percentage of range of the temperature, fan, and speed is 40%. And right now, the fan speed in hertz is 24%. So we're going to sit here for a minute and watch these numbers go up. All of these numbers should be going up, right?
Yeah.
As the temperature in Fahrenheit gets higher. We're at 40%. That water is getting pretty hot. It's 160 degrees. Now it's 162. Fan speed is 24 hertz. Twenty-four and a half hertz. What if we told it that when it's between 165 degrees Fahrenheit, we want it to be 0%, and at 175 degrees Fahrenheit, we want it to be 100%? Could we do that?
Yeah.
Just for fun?
Yeah, since we have all the math done for that, wouldn't that be as simple as doing like the greater than or equal to
All we have to
values?
do is change the range, right? So I'm going to turn the heat off for a second. Change the let's see, percent of the edge of the range. So F82. So we want this to be we want to take F80. What do we say? 165. So we want to take temperature in Fahrenheit minus 165 divided by 10, which is just the range of 175 to 165. And multiply that times the range of so that'll give us the percentage of fan speed so we take F82 times that range and add it to 6241. Cool. So right now it's at 50% because we're at 170. See what I'm saying? So what we did is we want to make this thing, when it's 165 degrees Fahrenheit, we want it to be 0 hertz. When it's 175 degrees Fahrenheit, we want it to be 60 hertz. So right now we're at 77% of that range and we're at 40 hertz. It should be cooling down because I got the heat turned off, but if I I was gonna say if I could turn this back on, then it would go back up. It just takes a while for the water to heat up and cool down. Anyway, that was just for fun. I'm done.
That's cool. Thanks, Zach.
You're welcome. Now it's going up. $173. Water's steaming. All right. Everybody good?
Yeah.
Yeah, I think so.
Questions?
Well, good
Everybody
here.
comfortable with next week?
Try to be.
Yeah.
What time do we need to be here on Monday?
9.
9 a.m.
Did everybody see the email I sent out with the new Zoom link?
Yes.
Nope. But I'm looking at. I'm gonna look at it now.
Yeah. Just it's a different Zoom link. But everybody should have gotten an email about it.
All right.
All right. Well, I will see you guys on Monday. Let me know if you have any trouble with anything. Get everything turned in, please.
Yep.
And I'll see you on Monday.
Have a good weekend, everyone.
You too.
Dope.
Me too.
Laters.